Hello everyone, welcome back. So today's topic is going to be on the concepts of pointers in C. This is video number 2, lecture 2 that I'm posting here. So now what today I'm going to teach you is regarding the concept of address of operator, ampersand operator and dereferencing operator. Okay, this is a very important concept in pointers. So I would request everyone to go through the video thoroughly so that it will be very easy to understand the basic working of pointers. How do we retrieve data using a dereferencing operator, which means the star operator. I'm going to teach you about the star operator. Okay, so before that, let me just brush up with the definition of pointer variable. What is the definition of pointer? A pointer is a special variable that holds address of another variable, which means any variable which is declared as pointer. This is how we declare a pointer variable. So this is how we declare a pointer variable. How do we declare? It is data type space star operator then pointer variable name. What does it mean? Integer is the data type, which means PTR is a pointer variable that holds address of some other variable, where that variable should hold an integer data. Okay, so whichever variable it points, the address of any variable, that particular variable should hold what data type? Integer data type. Okay, so any pointer variable should be prefixed with star operator. Only then that particular variable will be considered as a pointer variable. Okay, so now let me move on. I'll give you the other names of address of operator and dereferencing operator, which is very important 2-mark question and which is related to placement question also. So address of operator, which is usually referred as ampersand operator. The another name for address of operator is a reference operator. It's also called as reference operator. Okay, but dereferencing operator, dereferencing operator, which is referred with star, is also called as indirection operator. Okay, so there are two names. We can call address of operator, ampersand operator, as reference operator. Dereferencing operator, star, is also called as indirection operator, which is a very important 2-mark question, as well as very important when it is related to placement questions. Okay, so now let me move on. Writing C program using pointers concept. Okay, so I'll just write only the code snippet, the basic code snippets. Then I'll execute and show you the live execution of the pointer concept program. Fine. So I'll just write only the code snippet here. Suppose I have two variables, int a initialized with 10, b is equal to 20. I'll use one more variable c which is not initialized. Okay, so I'm using three variables here: a normal variable a with value 10, b with value 20, and c. So after this, what will be the memory reference after the execution of this particular line? Okay, so what will happen? Memory space will be allocated for a, b, and c, right? So you have three memory spaces for a, b, and c. Just for the understanding purpose, I'll draw and I'll teach you. Okay, so coming here, suppose after this particular line, if at address 1000, value a, variable a, okay, variable a will be stored. Fine. Then at address, assume at address 2000, variable v will be stored, and address 3000, c is stored. Okay, this is just an assumption here. And what is the value here? Value of a is 10, right? Value of a is 10, value of b is 20. So value of a is 10, value of b is 20. But value of c we haven't given, so it is empty, right, after this particular line. Okay, then I'll declare a pointer variable in star. I'll use two pointers, ptr1 star ptr2. Now there are two pointers. Okay, so immediately after this line, the memory reference, because after every declaration means reserving memory space and giving names to a variable to hold the values. This is called as declaration statement. Now after pointer declaration also, we will have two more memory spaces for pointers, right? One is for ptr, the other one, ptr1, the other one is for ptr2. Got it? So each and every variable a memory space will be assigned. Okay, so assume at address 4000, at address 4000, ptr1 memory space is reserved, and at address 5000, ptr2 memory space is reserved. Okay, what are the values? Okay, after this particular line, I'll give ptr1 is equal to address of A. Got it? ptr2 is equal to address of B. This is how you initialize pointer variable. Initialize pointers. Okay, this is how you initialize pointers. So after declaration, these two are declaration statements, right? They are declaration. This line is declaration statement. The other two lines are initialization statements. Okay, so this is how you initialize a pointer variable, and this is how you in a equal to 10 using equality, using assignment operator, we initialize a normal variable. Okay, this is how you initialize, which means address of A, right to left associativity, address of A is given to ptr1. Okay, now what will be here after these two lines? Address of A, what is this? Address of A is ptr1. Where is A stored? At address 1000. So ptr value will be 1000. The next line, ptr2 is equal to address of B, which means address of B is stored in ptr2. What is address of B? 2000, right? So ptr2 will be 2000. Got it? So these are the memory references of these two lines. You understood? But C, nothing is there, but address of at 3000, C is been reserved. Okay, C is being placed in the memory at address 3000. Okay, now these are the four lines of my code. Now after this, after initialization, just observe what I'm doing here. I want to print the value of A. What is the statement to print the value of A? Using normal printf statement. Printf value of A is equal to, I'll use the format specifier %d because it is integer data type. And if you observe, int star ptr, which means ptr1 is pointing to address of A, right? But what is the data type of A? What is data type of A? It is integer, right? That's why ptr1 pointer has the data type integer. It is declared with integer data type. Okay, similarly ptr2 is also integer data type because it is pointing to address of another variable. What is the address? B, but what is the data type of B? It is integer. That's why we have declared two pointer variables as integer. Okay, so I need to print the value of A. What is the value of A? It is only A, semicolon, enter. Now what will this do? It will print the value of A as 10. What is the value of A? It is 10. So what is the value of A? Output will be A is equal to 10, right? Next line, print f value of A is equal to %d. I'll use star ptr1. Observe this, star ptr1. Now what is a star? This is equivalent to star ptr1 is equal to address of star A. It will be star of address of A. Observe. Okay, now observe here. So star ptr1 is equal to, what is this? Star of what is address of A? Address of A is 1000, right? So 1000. What will happen? So star of ptr1 will be star ptr1 is equal to, at 1000 what is the value? At 1000 what is the value? 10. So star ptr1 is equal to 10. Got it? So in order to retrieve the value of A using PTR, because here if you see what is PTR, PTR1 is equal to address of A, which means now PTR1 is pointing to A. Okay, PTR2 is pointing to B, right? Okay, so when I want to display, when I want to retrieve the value of A, I can use the statement value of A is equal to A, or with the help of pointer variable, because pointer is also pointing to A. Okay, PTR1. So what I'll do, I'll make use of star PTR1. So what is star PTR1? Star PTR1 will work like the star of address of A, star of 1000. So you star and address of that particular variable. So it will go and retrieve 10. So the output will be again here A value of A is equal to 10 using PTR pointer variable. Got it? Understood? Understood the statement. Later on when I execute, you will understand very easily. Next one. See the next line. Printf. I'll print the address. Address of A is equal to. In order to print the address value in terms of hexadecimal, the format specified will be %x address of A. You remember in scanf we used to use the address of operator, same thing. Okay, so address of A, it will print the address of A. Here it is 1000, but when I'm printing here percentage is hexadecimal value, it's just an assumption here, 1000, 2000, 3000. There in the output you will get some hexadecimal value as the output. When I execute, you'll be able to visually see the actual output there. So it will be the hexadecimal value of A, so the address of A. Okay, then printf address of A is equal to, again, percentage x hexadecimal value. Now using ampersand, using a normal variable, I try to retrieve the address of A, right? Now what is PTR1? It is pointing to address of A. Shall I write PTR1 here? What will PTR1 display? It will print the address of A, right? So I'll get the address of A in hexadecimal. The same thing here also, you'll get address of A as hexadecimal value. Got it? Okay. So PTR1, what is PTR? See the PTR1 value here, it is 1000. Address of A, it is 1000. So these are these two statements that will print address of the variable. The same similar thing you can use for B also. Okay. Understood. Next one. Suppose, now just assume C. I have declared one more variable C. Now there is one more point here, C. Okay. Now C, I'll just change. C is equal to star PTR1. C equal to star PTR1. What does it mean? C equal to star PTR1. What is star PTR1? Star PTR1 has 10, which means it directly points to the value of that particular variable. Okay, so what will C have? After this particular line, what is the value of C? I'll try to print the value of C. Printf. Okay, rather than writing this here, I'll do one thing. Okay, immediately after this line, I'll paste C is equal to star PTR1, printf, value of C is equal to %D, and I'm printing the value of C. What will be the value of C here? C will have 10 because C is equal to star PTR1. Okay, there's one more line here. I'll just change. I'll change star PTR1 is equal to 30. What I've done here, star PTR1, immediately after this line, C equal to star PTR1. What is the value here? Star PTR1, so C value will be 10, right? After this particular line. Next, printf value of C equal to %C, so I'm getting C value 10. Star PTR1 is equal to 30. Now what will happen? It will move to this particular from pointer star PTR1. Instead of 10, it will be, instead of 10 you will have 30. Instead of 1, you will have 30 after this particular line. Okay, now let's try printing. After this line, I'll write value of a is equal to percentage d. Print the value of a. Then what is the answer you will get? You will get the value of a as 30. Why? Because I'm changing the value of 30 here. From 10, it is moved to 30. Understood? Understood the concepts here? Got it? Clear? So now this is the basic concepts of using dereferencing operator. What is dereferencing operator? The star operator is called dereferencing operator, and ampersand is called as referencing operator or address of operator. Okay, the basic concept of what you have to understand is declare normal variables, assign values to that, then declare a pointer variable. Immediately after declaring pointer variable, these lines are must, which means address operator is must. You got it? Okay, only then pointer variable will hold the address of that variable, and it will directly point to that memory reference of another variable, where we can change the value using the pointer variable directly inside the memory. You got it? Now I've used only ptr1 pointer. You can make use of ptr2 pointers here. Clear? Then I'll teach you a few more concepts here which is related to placement. Okay, now for example, I'll add the sentences here. I can give ptr1 is equal to address of A, comma address of B. Is it valid? Now see this particular line. See this particular statement. I'm assigning ptr1 is equal to address of A, comma address of B. What will happen? What is the value of ptr1 now? ptr1 will be address of A or address of B. So it will be address of A, because there are two operators here. One is assignment operator and the other one is comma operator. Okay, which has higher priority? Assignment operator has higher priority. So what will happen? ptr1 is equal to address of A will be assigned, which means address of A is assigned to ptr1. Okay, but address of B will be ignored because it is not pointing to anywhere. You will not get any error, but ptr1 will have address of A. Okay, now suppose if I change like this, ptr1 is equal to address of A, comma address of B, then what will happen? What value will it have? Because priority moves to parenthesis. Associativity is from right to left, which means ptr1 will have the value of B, address of B. You got it? Understood? With parenthesis and without parenthesis. Without parenthesis means it will move from left to right. Okay, so first this particular expression will be evaluated and this will be ignored because nothing has been assigned here. Okay, it will be considered as one expression, comma another expression. But when I put these two expressions within parentheses, then it takes higher priority, which means it moves from right to left. So ptr1 will have address of B and it will not have address of A. So this is one of the placement question and 2-mark question. Okay, now we understood. So let me teach you the execution part of this particular code. Okay, now let me teach you the execution part of this particular code. Okay, so what was that? The first line will be hash include stdio.h. It is the header file for C program. Then I'll use int main. So within main, we have declared int a is equal to 10, correct? B equal to 20, and initially see nothing was being initialized. Then I'll use two pointer variables int star ptr1 star ptr2. Okay, then ptr1 is equal to address of A, then ptr2 was equal to address of B, right? Then what did we do? Printf value of A is equal to percentage D. I'll use /n in order to print the next statements in the new line. Then A, so this will print the value of A. Then printf the same. I'm trying to print the value of A is equal to percentage D, again /n, using pointer variable ptr1. So using dereferencing operator star ptr1. Got it? Okay, then return 0 because the return value of main is int. Okay, now let's run the code. See, value of a is equal to 10, value of a is equal to 10. Let me change using pointer variable so that you can easily differentiate. Let me run the code. See, value of a is equal to 10. The line number 10 will be executed like this. Then value of a using pointer variable is equal to 10. You got it? Okay. Now, I'll add few more sentences here. I'll try to print the address. Printf address of a is equal to percentage x slash n, comma, using address operator, address of a. Okay, correct. Then printf address of a is equal to, again, percentage x backslash n, comma, ptr1, right? Okay, since I'm using percentage x here, you will get some warning when I run because it is online compiler. The other editors, you will not get any warning. It is not error, please note. It is just warning. Okay, now let's run the code. See, it's just the warning here that I'm getting. See, what is the output? A is equal to 10. Value of a using pointer is equal to 10. Okay. Value of a is equal to 10. Value of a using pointer is equal to 10. See, address of a is equal to 27FBD470. It is hexadecimal value. Similarly, address of a is equal to 27FBD470 using PTR. Okay. This I'll write using variable. Let me run the code. See, value of a is equal to 10, value of a using pointer, and address of a using pointer variable, the same address that you get. Okay, fine. Okay, now see the code here. What I'll do, I'll try to change. What did I do? I did c is equal to star ptr1, right? Which means I'm trying to store what was the initial value of c. Nothing was here, right? So I'm giving c is equal to star ptr1, which means value of a using dereferencing operator or indirection operator, that will be stored in c. Please note, this kind of sentences are called as dereferencing operator or indirection operator. Okay, now let me print the value of c. Printf value of c is equal to percentage d backslash n c. Okay, now let's check what is the answer. Let me run the code. Value of c is equal to 10. Why 10? Because star ptr1 is address of a, right? Star ptr1 will give you 10 because ptr1 is pointing to a and it will go fetch the value of a as 10. But now here I'm trying to store value of a into c, but using pointer variable, not using c. Okay, this statement is also equivalent to c is equal to a. C equal to a means a value of a is stored in c. Similarly, star ptr1 means value of a will be stored into c. You got it? Now observe, I'm doing, okay, after this line I'll change so that it will be easy for you to understand. Star ptr1, I'm changing the value of a using star ptr1 is equal to 30. Then I'll printf value of a is equal to percentage d, but here I'll try using variable a. Let's check what exactly is happening. I'm trying to print the value of a by changing star ptr1 is equal to 10. Okay, let me run the code. What happened? Value of a is equal to 30. I'm not printing star ptr1, but I'm just printing a value, right? Which means it directly goes into the memory and it changes the value of a because ptr1 is pointing to a. You got it? So I can directly change the value of a. I'm trying to print the value of a here, right? Understood? You're clear? Okay. See one more sentence. Printf address of pointer variable. Address of pointer variable ptr1 percentage x backslash n address of ptr1. What will this do? This particular line, it will print the address of the pointer variable. I'll just give backslash in here. Let me run the code again. See, address of pointer variable. Value of a address of pointer variable ptr1 is f69028. So even pointer variable address you can print because this is another memory space, right? Okay, clear? So I hope you understood the basic concepts of declaring a pointer variable. This is how you declare a pointer variable. Initializing a pointer variable, these three lines are must. Then how to retrieve the value of a variable using dereferencing operator. How can we change the value of of the existing variable using pointer variable? Okay, thank you.